Hello again. Today we're going to work on a problem that has a little bit of physics in it. What we have here is two particles that are moving along the x-axis. The first particle, particle P, has a position function, and that position function is valid only between 0 and 8. While the other particle, instead of a position function, we have a velocity function. And the velocity of particle Q is given as a polynomial. We are told that the initial position of particle Q is 5. And I say that's the initial position because that's the position at time t equals 0. So, for the first question here, question A, they're asking you when is particle P moving to the left. So for particle P, we know the position function, which is the natural logarithm of this polynomial. And when they ask when is it moving to the left, then when they ask for the direction of motion, we always look at velocity, especially if it's in one dimension, because your velocity will tell you if you're going in the positive direction, which in this case, that'll be to the right if it's positive, or the negative direction, which in this case will be moving to the left. So we'll take a look at the velocity function, which is the derivative of our position function. And the derivative of the natural log here is 1 over the argument of the log, and then we do a chain rule, we'll multiply by the inside of the natural log, which has a derivative which is 2t minus 2. We're going to set this velocity equal to 0, and we need to solve when the numerator is equal to 0. And that happens at t equals 1. Hopefully you can see that. Move the 2 to the other side and divide by 2. I was thinking if I need to worry about the denominator. You probably are thinking the same, but the function is defined, your position is defined from 0 to 8, which makes me think the velocity should be defined as well from 0 to 8. You can check if you have a calculator. You can graph this polynomial, this polynomial here, and see if there are any zeros, and I think there won't be any, meaning that the only thing we need to worry about then is the 1 in the numerator, and then which makes the whole thing 0. And then what we do is we plug this into our velocity. We plug in numbers that are to the left and to the right of 1. Remember that the function is only valid between 0 and 8, so we need a number between 0 and 1 and a number between 1 and 8. So if I choose t equals half and I plug it in here, half of 2 is 1, minus 2 is negative, so the numerator is going to be negative. And if I plug in half in the denominator, then I'll get 1/4 minus 1, which is a small negative number, plus 10. So that's going to be a positive number. So negative over a positive gives us a negative. So the particle is moving to the left between 0 and 1. What happens if we plug in a number larger than 1? Let's plug in 2. I know, that's very creative. So plug in 2 on the top. 2 times 2 would be 4 minus 2 is 2. That gives me a positive number. In the denominator, 2 squared is 4, minus 2 times 2, 4. That's 0, plus 10 is 10. That's still positive. So that's going to be positive. So then, to answer question A, particle P is moving to the left in the interval between 0 and 1. That should be less than equal. There we go. Okay, let's see if we can answer part B. And there are 2 more questions on the next page. So let's see. Now they want us to find all the times when the 2 particles travel in the same direction between t equals 0 and 8. So what we need to do is we need to look at the velocity of particle Q, and figure out when it's positive and negative. And then we'll take a look at the number line for this particle's velocity and then for the previous one, and see when the particles have the same sign in the same region. So this time we set this to 0 again. We can factor. 3 times 5 is 8. And then that will be negative 3 and negative 5. So this time we have 2 zeros. One is at 3 and the other one at 5. T equals 3, t equals 5. Now, note that we didn't have to take the derivative because we already knew the velocity. Unlike in the first case where we were given position and we had to find the velocity. So, let's plug in numbers between 0 and 3, 3 and 5, 5 and 8. And let's see when the particle is moving left or right. So if I plug in 1, my first factor over here is going to become negative. And the second one is also negative. So then the overall product is positive. Between 3 and 5, plug in 4, then the first factor is positive, and the second one is negative. So that's going to be negative. And finally, between 5 and 8, let's plug in 6. 6 minus 3 is 3, which is positive. And 6 minus 5 is 1, which is positive. Okay? So when are these 2 velocity graphs, when do they have the same sign? So the first one is negative from 0 to 1, but the second one is not negative at the beginning. It's negative between 3 and 5. So they definitely don't have the same sign from 0 to 1. And they also don't have the same sign from 3 to 5, which should be here somewhere. Because the second particle is negative and the first one is positive. They do have the same sign everywhere else. So not from 0 to 1, but yes, from 1 to 3, this particle is positive, and then the other one is positive as well. And from 5 to 8, they're also both positive. So the answer is the particles. Let me say it another way because I'm running out of space. Q and P move in the same direction from 1 to 3. Okay, for t in the interval from 1 to 3 and the interval from 5 to 8. Okay? I believe their next questions have to do with the same equations. Let's move on. Find the acceleration of particle q at t equals 2. So for particle q, we know the velocity, and then we want the acceleration. So remember that acceleration is the derivative of your velocity. And so let's go back and look at what was the velocity of particle q, and that was t squared minus 8t plus 15, which gives us an acceleration of 2t minus 8. This is your acceleration as a function of time, which means that at 2, the acceleration will be -4. Now, it's important to include units here, so acceleration would be in meters per second. Now, is the speed of the particle q increasing, decreasing, or neither at t equals 2? So, to be able to say if the speed is increasing or decreasing, what do we have to do? Well, what we do is we look at the velocity at 2, and we also look at the acceleration. If your velocity and acceleration have the same sign, then the particle will be speeding up. If velocity and acceleration have opposite signs, then the particle is slowing down. So let's see. At 2, if we plug in 2 into that velocity equation, well, we can do a calculation, but we already did a velocity number line, and at 2, which is here, the velocity came out to be positive. Now feel free to plug in 2 and check my work. Then now the acceleration is negative. So then, because they have opposite signs, then the particle is slowing down. Hope that makes sense. And let's see if we can do the last problem here before we end this video. Find the position of particle q the first time it changes direction. So let me take another look at, let's see if I can take this with me. We're going to look at the number line for this velocity of particle q, which is going to help us figure out what is the position. So let's get rid of these things. So when is the first time that the velocity changes direction, that the particle q changes direction? So it starts moving to the right, and then it moves to the left at 3. So the first time it changes direction is at t equals 3. So if we integrate the velocity function from 0 to 3, that is going to give you the displacement, which is the difference in your position. It's going to give you your position. Sorry. Sometimes they use S for position, but we're using X. So it's going to give you the final position at 3 minus the initial position. Work. Now, the initial position was given. That was 5. And we want to solve for the final position, which is this guy. So when we integrate our velocity function, this guy right here, we'll get a number, and we'll be able to solve for the final position. So, I don't feel like doing the integral. Sorry, guys. I hope this is clear. I guess I will do it anyway. From t squared minus 8t plus 15 dt. So this integral is going to be t cubed over 3 minus 8t squared over 2 plus 15t. Whoops, from 0 to 3. And we'll plug in 3, and then we'll plug in 0. When we plug in 0, we get absolutely nothing. As I always say, 0 means nothing to me. And let's see. We basically just plug in 3, and I'm going to plug in and simplify at the same time since I'm running out of space here. So plug in 3. 3 cubed is 27. Divided by 3 is 9. Then we'll do 4 times 3 squared. So 4 times 9 is 36. Come on, go away. 4 times 9 is 36. Plus 15 times 3, which is 45. So that will give us 36, 9, and what is this? 9 minus 36, that's 25. Is that right? 27. Negative 27 plus 45. I believe that's 18. Is that right? No, that's 27. No, is it 12? It is 12. My mistake. I should pause the video and do this. Sorry for being lazy. 9 plus 45 is 54. 54 minus 12 is not 36. Alright. So, I was right the first time. This is 18. Sorry about that, guys. Whew. Okay. So, so this integral, which is your displacement, is the same as the difference from the final position, which is what we're looking for, the position at x equals 3, which is the first time the particle turns around, minus the initial position, which is 5. So add 5 to both sides, and we get that the position at t equals 3, which is the first time that the particle turns around, is 23. And that would be 23 meters. Hope you found this helpful. I'll be back tomorrow with another problem. Thanks for watching.